Hello class, today we're going to talk about transformational geometry. What is it and what do I need to know? Well, this is part 3 of a 5-part series on transformational geometry, and in part 3 we're going to talk about reflections. Now a reflection is something that we're very familiar with because we look at one every single day. A reflection is nothing but a mirror image, or in relation to one of these shapes here, a flip. And we're going to flip it over a line of symmetry. So this line of symmetry right here is what I'm flipping it over. So what we need to understand about this reflection is that when I look at each of the points on the object, that they are the same distance away, just on the opposite side of the line of symmetry. And whether we're flipping it over the x-axis or the y-axis, it works that way. So let's see if we can actually look at a shape here. It says we're going to reflect this object, this arrow, over the x-axis. Okay? Now in order for us to do that, we need to focus on one individual point. Okay, so I'm going to focus on this point right here. Okay, and I'm going to write that coordinate down. And that coordinate is 4, 1. And what I want to now do is I want to reflect this over the x-axis. Okay, now when I flip this, I'm going to press on it. It's going to flip it, but it flips it the wrong direction, so I got to move it. Okay, so I'm going to flip it here. I'm going to make an image of it, and then I'm going to move it down into its right spot. Okay, so now you'll notice that it's one away to the top of the line of symmetry, one away to the bottom of the line of symmetry. So now that's how I know that it's a true reflection. So I'm looking at that point. So this point right here was the one I started with, and this is its corresponding part on the reflected image. So what is that coordinate? Okay, that coordinate is 4, -1. So what happened? Okay, our coordinate here, our x value, it stayed the same, but our y value turned to its opposite. So that's why we got to remember and we got to understand that when we're writing the algebraic representation, this x, y is our original coordinate, no matter what it happens to be. And then we're going to change it or transform it into a new coordinate. So in this particular one, what did I do with my x? Well, my x value, it stayed the same, but my y value, it turned to its opposite. So that doesn't mean a negative y, that means the opposite of what y was originally. Okay, so it doesn't matter if our values were positive or negative, it's going to turn to its opposite. Okay, let me show you what I'm talking about. I'm going to reset the page, and I'm going to take this figure here, and I want to move it down to this location right here. Just move it right there. And we're going to focus on this point. Okay, so if I want to reflect this object, okay, I'm going to double it here, and then I'm going to move it to where it needs to be. So right here it's 3 away, so I need it to be 3 away, and it is. Okay, so my original coordinate was -3, -3. Okay, so now look at its corresponding object, which is right there, its corresponding point. And that coordinate is still -3, but what kind of 3 for the y? It's now a +3. So again, what we're looking at is our original coordinate, no matter what it was. In this particular case, it was -3, -3. Okay, well, what happened to it? Well, my x value stayed -3, but what did my y value do? My y value turned to a +3, which means it's the opposite of what y was originally. All right, so let's now look at what if I reflect it over the y-axis. Well, on the x-axis, you'll notice that when I flipped it over that x-axis, that image kind of moved up and down, changing my y value. Okay, so hopefully what you understand is that if I reflect it over the y-axis, that it's going to be moving along the x-axis. Okay, so again, we're going to do the same thing. We're going to focus on an individual point. So I'm going to focus on this same individual point, and that point was 4, 1. Okay, so this time whenever I reflect it, again, I will have to move it. Okay, now let's see if it's going to work now. Now it worked. Okay, so I move this into its position, and I'm focusing on this point right here. So there's the point that I want. So what is my new coordinate for that? Well, that new coordinate is -4, +1. So here's my original coordinate of 4, 1. What happened to that coordinate? Well, that coordinate actually turned to what? Okay, my x value this time turned to an opposite, and my y value stayed the same. Okay, so whenever I'm reflecting it over the x-axis, it's moving up and down the y, so my y value is going to change. When I reflect it over the y-axis, it's moving along the x-axis, so my x-axis is going to change, or my x value, my x coordinate. But what I need you to understand is that my x and my y do not trade places. We'll talk about more of that in the next video. But why do I need to know this? Well, again, here's a typical question that you may have. The coordinates of the vertices of quadrilateral PRST are as follows. 1, 2, 1, 4, 3, 4, and 4, 2. And it makes a nice little rectangle, in this case a square. And it says quadrilateral PRST is reflected across the y-axis. So I'm reflecting it across the y-axis. So that means it's moving along the x-axis. So which value turns negative? The x value turns negative. So when I look down here, I see that this one is the one that's going to reflect across the y-axis. But if you'll notice, C and D, my x and my y rotate. Okay, they change places. Okay, so we need to make sure that we understand that those are not reflections. That reflections, just my x and my y, are going to turn negative. But in the next video, we'll find out what these are. So that's the end of part 3.